Hey Bengals, today we're going to start our motion graphs lab. Today you'll be working with slides, and then tomorrow you'll do the analysis portion in Schoology. So you want to make sure you understand the slides really well. If you're here to check your answers, you can kind of skip ahead and see what you need to see. If you're here because you need a little bit of help on the slides, then stick with me and we'll go through this together. Okay, so we're going to be using the Bike Guy website so that we can create our own motion graph labs. And this is how it works. Hey, you've got a little guy on a bike here, and you have a start clock and a stop clock, and then right here you'll see a blue line as your guy moves. 0 is the origin, and then we're going to hit start to get our guy to begin cycling along. There he goes. As we drag him along, you can see that the graph is created, right? As he moves closer and away from the axis. You press stop when you want it to stop. You can reset your cyclist, and when you're ready to begin, you'll just press start clock again. It'll start you a new graph. So you might have to try some of these graphs more than once just to get them to look right. I certainly did myself. Okay, so have a little fun with this. All right, so let's get started here. This is a graph number one of just a flat line. So we're going to write our answers in the gray box to the side. It says this graph shows what? So think about the notes that you already took this week. What does a flat line show on a motion graph? Well, it shows that the distance doesn't change. And if the distance doesn't change, that means you're staying in one place, right? But time carries on. So the line continues on across the time. Okay, so it shows no motion. Now notice this flat line is not at the x-axis. It's not at the origin. It's kind of up away from the axis. So it's some distance away from the origin. So now how do we make this on the simulator with our bicyclist? Well, before we start the clock, we need to move our cyclist away from the 0, and then we need to keep him very still. So let's see how that would work. I move the cyclist away from the origin and I click start. The line is created and it's just like it was on our graph. And when I'm done, I can click stop. Okay. All right. That one wasn't too difficult, right? So let's kick it up a notch. Let's look at this one. This one is one straight line away from the origin. So what does that graph show us? A straight line shows us a constant or a steady speed. And in this case, it's moving away from the x-axis, which means we're moving away from the origin. So how could we make that on the simulator? Okay, so what we need to do is try to get our cyclist to ride at one constant steady speed away from the start or 0, the origin. So let's give it a try. I'm going to click start. And then I'm going to have my cyclist drive very nice and steady. It's harder than it looks, trust me on that, away from the origin. Now you will notice there was a little flat line here where no motion occurred. The reason for that is I had to have time to move my cursor from the start to the cyclist to get it to move. Okay. All right, the third slide of graphs. This one looks very similar to the one we just did, right? Except that it's a little bit steeper. So what does that tell us? That tells us the cyclist is still riding away from the origin at a constant, steady speed, but now the cyclist is riding faster, right? When a line is steeper, it shows that you have covered more distance in a less amount of time, a shorter amount of time. Okay, so it's different because it's moving faster. So let's try to create that. Got my cyclist on this 0 and I start, and this time the cyclist is moving much faster, so my line is steeper. Okay. Notice the beginning and the end still have that little stopping point, which I just can't help because I can't move that fast from the clicking of the start and stop clock. So we see that on there. All right, let's try another one. This looks similar except that the line is now heading toward the origin. So what does this graph show us? It shows us that the cyclist is riding at a steady speed, but coming back toward the initial point. Doesn't quite get there though, right? The line doesn't go all the way down to the origin or the x-axis. So how are we going to make this? Well, we're going to have to move our cyclist away from the origin to start and then have them ride back to the origin at a steady speed. So let's give that a try. Okay, so move our cyclist away from the origin so that they start up at the top of the distance part of the graph. Start the clock, and then have them drive at a steady speed back toward the origin. But we don't want to go all the way to the origin because it didn't show that on our graph, right? Okay. Now, we're getting really complicated now. It says, what does this motion graph tell us? Okay, this one even has the units of time in seconds counted off for us, which is going to make making this on the graph a little bit more challenging, but we'll do our best. So, this graph shows that the cyclist is starting away from the origin, 6 meters away. And then for 3 seconds, the cyclist walks toward or bicycles towards the origin. So it takes 3 meters, 3 seconds to get there. Then the cyclist stops for 4 seconds, then turns around and goes back where he came from for 3 more seconds and covers 3 meters again. So we're going to try to do that. It's going to be really difficult to manage our time, but we'll see if we can get it. Going to move our cyclist away. So we'll say that's 6 meters away. Start the clock. Have the cyclist ride toward the origin for about 3 seconds. Stop for 4 seconds. And then ride back away from the origin for 3 more seconds. Okay? Coming toward, stopping, and then back away. All right, and here's the big one of all. Ooh, this one's really tough. I have to tell you guys the truth. I had to do this like 12 times to get it right. Okay, so this one, how can we make this on the simulator? Well, let's take note. They start at the origin and then very quickly go 30 meters in 1 second and then turn right around and a little bit slower, they return toward the origin, 20 meters, and then pause for 2 seconds and then go away from the origin again. All right, so pretty tough. Let's see if we can do it. We start at the origin, quickly drive away, turn back a little bit, pause for 2 seconds, and then slowly ride off. Pretty good. Not bad. See if you can try it. It's harder than it looks, that's for sure. All right, so now that we've practiced with that, what do we know from a motion graph? You know the direction. Is it moving toward the origin or going away? You know the amount of distance because you look at the y-axis and see how much the distance is covered. You know the time because you look at the x-axis to see how long it took. And if you know the distance and you know the time, then you can calculate speed, right? Speed equals distance divided by time. So let's take a look at this. You have your distance time triangle, so you can calculate speed if you need help up there. So it says from point A to point B, what is the total distance? Well, here's A at 0 and here's B at 30. Okay, so the distance is from 0 to 30. So it's 30 meters. From point A to point B, what is the total time? For time, we look at the x-axis. So from A to B is here. Well, this is 1 second, right? Time is in seconds. This is 1 second. Okay, so now we use our speed formula. Speed equals distance divided by time. So 30 divided by 1. 30 divided by 1 is 30. So the speed from point A to B is 30 meters a second. Let's try a harder one. Let's look at point A to point C. Okay, we already know that it's 30 meters to B, but now the cyclist goes back We have to count up how far the distance is from B to C. Well, we go from 30 to 10. C is at 10. So 30 to 10 is 20 meters. So we went 30 up and then 20 back. So that's 50 meters in total. What amount of time from A to C? Well, A is at 0 and C is at 4 seconds. So from 0 to 4, we have 4 seconds. Now we have to plug it in. Remember, our distance is 50 divided by our time of 4. 50 divided by 4, use your calculator, there's no problem with using a calculator, is 12.5 meters per second. Okay, very last one, we're going to tell a little story. What could possibly be happening with this graph? A bird started blank meters from the tree. So blank meters, I don't know, but it looks like he's about 6 meters away. Okay, he flew to a tree at a speed of blank meters per second for 3 seconds. Okay, so 3 seconds is here. How far did the bird fly in 3 seconds? From 6 to 3. Okay, 6 to 3. So that's 3 meters that he flew in 3 seconds. Distance 3 divided by time 3. 3 divided by 3 is 1. Then the bird did what? Well, the bird looked like it stopped. It must have sat in this tree. Okay, so it stopped because it's a flat line, no motion. And how long did that occur? Count your blocks. 1, 2, 3, 4 seconds. Finally, it flew away at what speed? Okay, so we have to find our distance. So it went from 3 back to 6. So 3 to 6, 1, 2, 3 blocks. And then we need our time. So it started at 7 and went to 10. 1, 2, 3 blocks of time. So again, we have distance of 3 divided by time of 3. So it's 1 meter per second for the speed for that segment. Okay. Story time. Make a graph for the following scenario. A person started at 0 meters away from the motion detector. So 0 meters away means you're at the origin right here. Okay. The person walks forward at 2 meters per second for 3 seconds. So every second we have to go up 2 meters. So 2 meters per second. There's 1 second. 2 meters per second. There's 2 seconds. 2 meters per second. There's 3 seconds. Okay, so we draw that line. Then the person stops for 2 seconds. All right, that means it's a flat line, no motion for 2 seconds. So we draw that line. Finally, the person walks back at half a meter for every second and does this for 5 seconds. So half a meter every second. So there's a second, half a meter. 1 more second, half a meter. 1 more second, half a meter down. 1 more second, half a meter. And finally, we finish up. Okay? All right, so go back and make sure your lab is all correct. And if you need to review this or parts of this to make sure you have all your answers and you understand it, make sure your slides are ready to go because that'll certainly help you on your analysis portion tomorrow. Great job, Bengals. Bye-bye.